prefix for 10 to the power 6, and so on, so forth. Now, to study electrical engineering, we should be familiar of the fundamentals of electricity. And the basic principle of electricity is based upon the atomic theory, and we will begin as a review of this theory. The basic structure of an atom is shown in this figure. This is in its normal state. It has an equal number of electrons and protons, where this is the electrons orbiting around nucleus. Since they are equal and opposite, because the electron has negative charge while the proton has positive charge, this atom is electrically neutral. Electron orbits the nucleus, as we see, in spherical orbits called shells, designed by letter seen here, K, L, M, and N shells. It depends on the number of electrons whether all these shells are here or not, because each shell consists only of a certain number of electrons. For example, K shells has 2 electrons, L shells has 8 electrons, its capacity. M shells has 18 electrons, and N shells has 32 electrons. If this atom requires additional electron, then this atom is negatively charged, and if this atom loses electron, it is positively charged. All the inner 3 shells, K, L, and M, are filled, while M has only 1 electron. Means this electron in the M shell is called valence electron. It is the electron in the outermost shell. And thus, according to the arrangement of the electrons around the nucleus of that element, material are classified into 3 types electrically. Now we will talk about electrical charge. Substances in their normal state are also generally uncharged. That is, they have equal number of electrons and protons. The charge denoted by the symbol Q associated with a group of electrons is equal to the product of the number of electrons times the charge on each individual electron. Since the charge manifests itself in the form of forces, charge is defined in terms of these forces, and this is what is known as Coulomb's law. The force between 2 charges is equal to constant K, the charge in the atom 1, Q1, multiplied by Q2 over the square of the distance between them. So the amount of force is proportional to the product of the 2 charges and inversely proportional to the square of the distance between them. And this constant is measured. It is equal to 9 multiplied 10 to the power 9. And the electrical charge is denoted by the symbol Q, and which is equal to -1 0.602 multiplied 10 to the power minus 19 coulomb. The coulomb is defined as the charge carried by 6.24 multiplied 10 to the power 18 electrons. So like charges repel each other while unlike charges attract each other. The force of attraction keeps the electrons in orbit around the nucleus. Thus, what causes an electron or charge to move in an element? Material actually remains electrically neutral. Such electrons are called free electrons. They are the electrons in the outermost shell. In copper there are of order 1023 free electrons per cubic centimeter. Per cubic centimeter there are 1023 electrons. If this is 1 centimeter width and 1 centimeter long and height. There are another terminology which is the ions. If the atom loses an electron, it is called a positive ion. If it gains an electron, it is called a negative ion. So materials are classified into three types electrically: conductors, insulators, and semiconductors. Conductors are material through which charges move easily, are termed conductors. Actually, conductors are the material which has a lot of free electrons in its outermost shell, while insulators are material that do not conduct, such as glass, plastic, rubber, and so on. They are termed insulators. Semiconductors, they are half filled. Their outermost shell are half filled, such as silicon and germanium, plus a few other materials. They have half-filled valence shells and are thus neither good conductor nor good insulator, in between the two. They are known as semiconductor. They have unique electrical properties that make them important to the electronic industry, such as the transistor, the diode, transistors. They are the building block of modern computers. So, after knowing what is a charge, we will begin with the electrical current. Electrical current is defined as the rate of change of charge with time. It is the time rate of change of charge passing through a predetermined area. It is the change of charge with time. It's measured as coulomb per second. And this is a diagram shows the conventional flow of current in a closed loop circuit. We have here the battery. This is the symbol for a DC voltage battery. The current go from the negative terminals through the lamp and come back to the positive terminal. This is the movement of electrons through a wire. Electron flow in a conductor. Electrons, as we know, is a negatively charged. They are attracted to the positive pole of the battery. As electrons move around the circuit, they are replenished at the negative pole of the battery. This flow of charge is called the electric current. There are two directions of current. The conventional current direction by Benjamin Franklin in the 18th century is that the current flow from the positive terminal to the negative terminal, while the electron flow is actually from the negative terminal to the positive terminal. But most of the textbooks take the conventional flow of the current, which is from the positive terminal to the negative terminal. We have two types of current. If the current does not change with time but remains constant, it is a direct current, and this figure shows the direct current, DC current, such as in your cars, the current that is produced by the batteries.